Right, hello, welcome to another Oxford MAT video. This time we're on question F. So let's get into it. It says which of the following expressions is equal to log to the base 10, and then it gives you 10 factorial, 10 times 9 times 8 all the way to 1. And then it gives you a bunch of options. Now the key part to remember to this question is just remembering your log rules. If you can remember your log rules, you will be absolutely fine, and then it's just a matter of simplifying. So we start with log 10 times 9 times 8 times yada 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 all the way to 1. Now there are two important log rules to remember here. Log of AB equals log A plus log B. Log A to the B equals B log A. I mean, there's also the, and then by inference from this rule, you can kind of say that log B over A equals log B minus log A. So now that we have our rules, let's actually go and do some working out. So because we have, is the pen working? Yeah, because we have log 10 times 9 times 8 times 7, we can split this into log of 10 plus log of 9 plus log of 8 plus yada yada yada, and we split these things up into adding separate logs together rather than one big log which is multiplied. So now we can take each of these individual logs and convert them into something easy to work with. Now remember, this is log base 10, so log base 10 of 10 is just going to be 1. So log 10 to the 10 is going to equal 1. So the first thing we have here, this log 10 is just 1. Now we want log of 9. And the interesting thing to note from the answers is that the log answers are either in log to the 10 2, log to the 10 6, or log to the 10 7. Now can we turn this 9 into something that looks like a log to the 2 or a log to the 6? Well, yeah, we can. We can say that 9 is just the same as 18 divided by 2. And what is 18? 18 is 6 times 3 over 2. And so we can say that log 9 is the same as log 6 plus log 3 minus log 2. And this log 3 we will deal with later, but just ignore it for now, and we're just going to include it for now, and then we'll sort it out later. So we now have 1 plus log 6 plus log 3 minus log 2. And I'm going to rub out this working here. You can pause and rewind the video if you need to, and just because we don't really have enough space to on this particular slide to have all of the go through every single part of the log. So we have log 10, we have log 9, log 8. Now this incorporates our log A to the power B rule, because what is 8 if not 2 to the power 3? Log 8 is the same as log 2 to the 3, which is the same as 3 lots of log 2. So now we have another thing in terms of log 2, log 6, or log 7. So 3 log 2, we can add that to our list. Well, log 7, we can leave that. It's just log 7. And we can go on to log 6. Now 6, we can leave log 6, because log 6 is already in the form 6, 7, or 2. Log 5 Now this one took me a little while to figure out, but what is log 5 if not log of 10 divided by 2, which can be split into log 10 minus log 2. And what is and log 10 is just 1. So at this point we just have 1 minus log 2. So there's log 6, there's log 7, and log 5 is just 1 minus log 2. I'm underlining these things just so we can say that each part of our, just so we can track where each part of our new expression has come from. So I've underlined the 1 by itself, just so we know that that's come from log 10, and then you can count down. This on the line is log 9, log 8, log 7, log 6, log 5. Okay, so now we're on to log 4. And again, we're going to do the 8 trick again. Log 4 is log 2 squared, which equals 2 log 2. And that's it. Plus 2 log 2. There we go. Brilliant. Log 3, we're going to leave as log 3 for now. Nope, that's not what I meant to write. I'm going to just quickly grab the eraser and go to town. Obviously, if you were doing this question in an actual Oxford MAT, you wouldn't be going through this so slowly. You'd be kind of going through it a bit quicker, because you kind of be like the time element of it. But I'm kind of going through this slowly just to establish understanding. So log 3, we can just write that. Log 2, we can leave as it is. And log 1 is 0. Log to the 1 of anything, log to the base of anything, where it's log 1, always equals 0. Because this can be rewritten as a to the power 0 equals 1. And it doesn't matter what a is. A is always it doesn't matter what a is. A to the anything to the power 0 is always 1. I recently sat in on a class, I think of year 7s, year 8s, and they were learning this rule. So this is obviously something that you should know. But this kind of thing can be rewritten like this, and this is kind of what it needs you to know. So we don't need to write anything for log 1. We're just going to leave it because it is just 0. Now I said I'd come back to the log 3, which I'm going to do, but let's just organise our expression. Oh, I seem to have gotten rid of a box. Well, I'll get rid of this bit now anyway, seeing as we don't really need it. At this point we're just organising and we're just organising, simplifying, and now we have a lot more space on our slide. So if we start off with just the pure integers, 1 and 1, that's 2, plus, and let's count our log 6s. We have 1 log 6, we have 2 log 6, and for now that's it. That's supposed to be a plus, not a times. 2 log 6. So next we'll go to our log 3s. We have 1 log 3, plus 3, and plus 4. Is that what I've gotten? So I'm just checking my own working here. Plus log 3. Oh, I'm looking at log 2, aren't I? That's what I'm doing wrong. Sorry about that. So we've got 1 log 3 here. We've got 1 log 3 here. So we have plus 2 log 3. Now we count our log 2s. So we have minus 1. We have plus 3, so now we're at 2. Minus 1, so we're at 1. And plus 2, so we're at 3. And then finally we have 1 more, so we're at 4. So we have 4 log 2. And then we have our log 7. So already we're kind of thinking, right, it's probably going to be, we know it's going to be one of these things, because we're looking at the 2s. And we know we have a log 7, so it's going to be one of these two. So which one is it? But the problem is that these things that are there, they don't have anything in the form of log 3. So how can we get rid of our log 3? Well, it's that rule again, isn't it, with the what we did with 10. So what we did with 5, we're going to do to 3. So we're going to say that since 3 is the same as 6 over 2, log 3 is the same as log 6 minus log 2. So our 2 log 3 suddenly becomes 2 log 6 minus log 2. So we're adding 2. We've got 2 more log 6s, sorry, and we've got minus 2 lots of log 2. So we can add 2 lots of log 6 to our log 6, to our 2 log 6, which gives us 4 log 6. And we're subtracting 2 from our 4 log 2, which gives us 2 log 2, plus log 7. There we go. So our answer is 2 plus 4 log 6 plus 2 log 2 plus log 7, and that is C. And that was a bit of a longer one, but you know, I thought it was quite a fun one to do because there's a lot of little steps there. But yeah, now we're at the end of that question. Thank you for watching, and I'll see you in the next video.